In today's lesson, we are going to look at graphing certain types of rational functions. And we're going to do this by looking at vertical asymptotes, horizontal asymptote, and x and y intercepts, and finding other key points. There are many different varieties of rational functions. For today's lesson, we're going to focus on just a few different basic shapes. One that you should be familiar with is when you have one vertical asymptote and one horizontal asymptote, and then we have graphs like this that follow the asymptote. So we've graphed that type before, but now we're going to get into what if we have two vertical asymptotes and one horizontal asymptote. So one shape, a common shape, would look like this. And then another example, when we have two vertical asymptotes, is in the middle, it can actually go across that horizontal asymptote, but then follow those two vertical asymptotes, and then on the sides, we have here and here. So this is kind of the three main we're going to focus on today, and there's variations within those. Let's see, we have another one. Let's see, I could have one vertical asymptote and one horizontal asymptote, but this time they could both be above the horizontal asymptote. We're going to not have any super crazy in this lesson, but just to kind of give you a visual, you can have graphs that even do this on the inside, and it could cross the horizontal asymptote and then come back up. Rational functions can look pretty crazy. There's lots of different variations. But we're just going to, again, focus on these basic ones for today. So here is our first example, x squared minus 4 over x squared minus x minus 12. And our goal is to graph this without using a graphing calculator. So starting out, let's find our vertical asymptotes. Vertical asymptotes come from when we are setting our denominator equal to 0 and solving for x. So here I'm going to have, I can factor. So then I'll have vertical asymptotes at x equals 4 and x equals negative 3. So I can go ahead and draw those on here right away. And for horizontal asymptotes, we're going to look at the degree. So they have the same degree, numerator and denominator. So we're looking at the coefficients, 1 over 1. So there's a horizontal asymptote at y equals 1. And now we need to find some points. So I'd like to always start with finding intercepts. So x and y intercepts, if you remember from a previous unit, that's when we're putting in our zeros. So starting out, let's put 0 in for x. So when you plug in 0, we're going to have negative 4 over negative 12, so that's positive 1/3. So we'll just estimate that about right there. And then to find the x-intercept, we'll set the function equal to 0 and solve for x. So when you have a fraction and it equals 0, it's when your numerator equals 0. So x squared minus 4 equals 0. X will equal plus and minus 2. So I'll have negative 2 and positive 2. So let's plot those on there. Okay, so even though this is very slight, you can see that this part of the graph is going up and then back down. So then we know that the inside trend is going to follow those asymptotes down like that. So now we just need to find some other points. And when we're doing this, we're just going to find points that are near those vertical asymptotes. So we've got that vertical asymptote at 4. Let's plug in 5. Because 5 is just to the right of this vertical asymptote at 4. And then if we have a vertical asymptote at -3, let's find something to the left of that at -4. So if we're doing this without a calculator, it can get a little messy, but we can get a good estimate. And I'm going to start by factoring the top and the bottom, just because I find that that's easier to work with. X plus 2, x minus 2 over x minus 4, x plus 3. So the idea is that we're plugging in 5 into each of these factors. So 5 plus 2, I've got 7 times 5 minus 2, 3 over 1 times 8. So I have a positive 21 over 8, which is going to be in between positive 2 and 3. It's actually 2.625. So it doesn't have to be perfect, but I need to at least know essentially which part of the graph the point goes, because then I can just go through that point and follow asymptotes. So we're just kind of getting a sketch, but getting as accurate as we can without a calculator. Okay, so now -4, let's plug into each of these factors. -4 plus 2, so I have -2 times -6 over -8 times -1. So that is positive 12 over positive 8, which is 3 over 2. So if we plot that, that's going to be left 4 up 1.5, and then we can follow the asymptotes. So there we have a sketch of this function, and we were able to do all of it without a calculator. Okay, let's do one more example. So here I have x squared plus x minus 12. And then over in your lesson today, you'll find that some of them are in factored form. So I've got x plus 1 times x minus 4. All right, so let's start. Vertical asymptotes. So that is when the denominator equals 0. So vertical asymptote at -1 and at 4. And go ahead and graph those right away. Okay, horizontal asymptote. If you were to FOIL this out, you'll have that x squared on the top, and then we'll have x squared on the bottom. So once again, we have same degree coefficients 1. So we again have horizontal asymptote at 1. Okay, so now let's do intercepts. Let's first plug in 0 for x. So when we plug in 0, we'll have -12 over -4, so we get positive 3. So 0, 3. And now let's set the function equal to 0. Remember, when you have a fraction equal to 0, really we only care about that numerator. So we're going to set x squared plus x minus 12 equal to 0. So x plus 4, x minus 3 equals 0. So then I'll have intercept at -4 and positive 3. So let's graph those. Okay, so let's see what this gives us. Notice how in this one, here we have in the middle between two vertical asymptotes, we have a point above this horizontal asymptote and below. So for today's lesson, we can assume it's going to follow this trend. going through both of those points and following those asymptotes. And then here we've got this one. So let's get another point on the other side of this asymptote. So let's plug in 5 and we'll see where that point takes us. So if I plug in 5 to each factor, I will have 9 times 2 over 6 times 1. So 18 divided by 6, oh, that's an easy one, 3. So over 5, up 3. So we'll have a point here, and then we can follow those asymptotes. So there is your full lesson on graphing some rational functions. These can get crazy once again, but we're going to try to keep things fairly simple. Find those vertical asymptotes, horizontal asymptotes, intercepts, find some other points, and then just get a good sketch of your graph. Good luck with your lesson.